Alright, today we're going to discuss three variable systems of equations. So, couple things to make note of. The solution to a system of equations with three variables, which is a typo in your note sheet, is the ordered triple x, y, z. And what that means is it satisfies all equations. So it's an ordered triple that satisfies all equations. We also need to make note that three variable systems can have one solution, you have no solution, or it can have infinitely many solutions. So, I've got some steps. So to solve a system with three variables, we're going to do the following. First, we're going to eliminate a variable from a pair of equations then eliminate the same variable from another pair of equations. Then in step 2, we're going to solve the resulting system of equations from step 1. Because then we'll just have two variables. Once we do that, we're going to use substitution to find the value of the third variable. And that's going to bring us into our first example. So example 1, we're going to solve the system x plus 3y plus 2z equals negative 13 for the first equation. The second equation is 5x plus 2y minus 2z equals negative 11. And then we've got 7x minus 4y minus z equals 29. So what I'm going to do is I'm going to take these first two equations and I'm going to solve them. I'm going to eliminate the z because I see with the z terms I've got the same numbers, just opposites. So we can call this step A if you want, or step 1. You call it what you want. We're going to take x plus 3y plus 2z equals negative 13, and then we're going to add 5x plus 2y minus 2z equals negative 11. So the z terms are gone. When I add the x terms, I get 6x plus 5y equals negative 24. Now for the second step, what I'm going to do is I'm going to take the second two equations, the last two, and I'm going to also eliminate the z term. So if we wanted to, we could call this step B, or step 2, whatever you want to call it. We're going to take 5x plus 2y minus 2z equals negative 11, and 7x minus 4y minus z equals 29, And I'm going to start by multiplying that entire equation by negative 2. So I'm going to rewrite this step B. We're going to have 5x plus 2y minus 2z equals negative 11. And then we're going to have negative 14x plus 8y plus 2z equals negative 58. And now we can just add going down because our z terms will cancel out. We'll end up with negative 9x plus 10y equals negative 69. Now I want a little bit more space because in step 3, I'm going to use the two equations we got from steps A and B to figure out my x and my y. So we ended up with a system of 6x plus 5y equals negative 24 and negative 9x plus 10y equals negative 69. Now I'm thinking I want to eliminate my y term. So to do that, I'm going to multiply the top equation by negative 2. So we're going to end up with negative 12y minus negative 12x minus 10y, equals 48. And then we're going to have negative 9x plus 10y equals negative 69. And then we can add these. Our y will cancel out. We'll end up with negative 21x equals negative 21. So if we divide by negative 21, we're going to get x equals 1. Well, there we go. Now we're going to take that and put it into one of the equations we had from above. So I'm going to just take the first one. No, I'm going to use the second one actually. I'm going to go negative 9 times 1 plus 10y equals negative 69. Negative 1 times 9 is negative 9 plus 10y equals negative 69. So if I add 9 to both sides, we're going to get 10y equals negative 60. So we divide by 10 and figure out that y is equal to negative 6. So we've got an x, we've got a y. Now we're going to take one of the very original equations to figure out a z. And I'm going to just take the very first one. So I'm going to take x plus 3y plus 2z equals negative 13 for no other reason than it's the first one. We could use the second one, we could use the third one. I just like to use the first. So we're going to replace x with 1, and we're going to replace y with negative 6, and then we're going to solve this for z. Well, 3 times negative 6, that's negative 18. So we're going to have 1 minus 18 plus 2 times z equals negative 13. 1 minus 18 is going to give me negative 17 plus 2z equals negative 13. So if I add 17 to both sides, we're going to end up with 2z, and I'm going to go up here in the corner to continue my work. 2z equals 4. So we divide by 2 to figure out that z is equal to 2. So our ordered triple in this case is going to go x was 1, y was negative 6, z we found to be 2. So our answer is 1, negative 6, 2. Let's look at another one. Let's look at the system 4x, so example 2. We're going to have 4x minus y plus 9z equals negative 3. We're going to have 3x minus 4y minus 5z equals negative 31, and negative x plus 7y plus 11z equals 27. So what I'm going to do to start this off, and you could go a different route than I am, but I'm going to take and I'm going to eliminate x in my bottom two equations. So let's start by rewriting that. We're going to have 3x minus 4y minus 5z equals negative 31. Now our goal when we're eliminating x in those bottom two equations is that the number in front of x should be the same but opposite. So the coefficient should both be 3, but we should have a 3 and a negative 3. So I'm going to multiply that entire second equation by 3, or the third equation. So we're going to have negative 3x plus 21y plus 33z equals 81. So then when we combine these equations, our x terms are gone. We're going to end up with 17y plus 28z equals 50. Now I can take any combination of my first equation and the other two to also try to eliminate x. I'm going to take the first one with the last one, and this time instead of multiplying by 3, I'm going to multiply by 4 since I'm trying to eliminate the x. So we're going to have 4x minus y plus 9z equals negative 3, and if we multiply the entire bottom equation by 4, we're going to get negative 4x plus 28y plus 44z equals 108. And then we can combine those. The x terms are gone. We end up with 27y. We add the z terms to get 53z equals 105. So we can set up our new system. We've got 17y plus 28z equals 50, and we have 27y plus 53z equals 105. We can eliminate the x or the y, it doesn't matter. In this case, I'm going to go and eliminate my y terms. Now 17 is a prime number, so I'm going to multiply the entire second equation by negative 17 and the top one by 27. I'm just going to take the numbers in front of the y's and multiply them. So if we multiply the entire first one by 27 and the entire second one by negative 17, we can achieve our eliminating of our y variables. So we're going to end up with, and go ahead, use a calculator to do the multiplication. We're going to have 459y plus 756z equals 1,350. Then we're going to end up with negative 459y minus 901z equals negative 1,785. Now we combine these equations. So the y terms are gone. We're going to end up with negative 145z equals negative 435. So if we divide by negative 145, we're going to find that z is equal to 3. Now we're going to take that and plug it into one of the equations we got from steps 1 or 2. I'm just going to take the first one. But I've run out of space on this page, so let's look at another page. So I'm going to go 17y plus 28 times 3 equals 50. And then I'm going to solve this for y. 28 times 3, that's 84. So we're going to have 17y plus 84 equals 50. So we'll subtract 84. 17y is going to equal negative 34. If we divide by 17, we're going to get y equals negative 2. So we've got a y, we've got a z. Now I'm just partial to the first equation. We're going to take that the y, negative 2, and the z that we got on the previous page, 3, and we're going to plug them into 4x minus y plus 9z equals negative 3. You could pick the other two equations. You're going to end up getting the same answer. So we're going to have 4x minus negative 2, so plus 2, plus 9 times 3 equals negative 3. Well, 9 times 3 we know is 27. If we add 2 to that, we're going to get 29. So 4x plus 29 equals negative 3. Let's subtract 29. So we're going to get 4x equals negative 32. If we divide by 4, we're going to get x equals negative 8, which means our solution is going to be negative 8, negative 2, 3. It's the ordered triple. I think I know I have more examples I want to go over, but for the sake of length of this video, we're going to call it good on this one. We'll look at examples 3 through, I'm hoping, 5 in our next video, and then if we can't fit any application problems in there, we'll throw those into a third one, and we'll only do some of the application problems from our guided note packet.